Okay, and for what we have with absolute value, okay, so we're going to throw in some symbolism here. Okay, so we have with okay, just symbolically. Okay, so the absolute value of x, okay, we have denoted by what would be vertical bars surrounding the letter x. And by definition, okay, so the absolute value of x for the absolute value of x, okay, this is going to be the number of integral steps that x is away from 0 on a number line. And in the case of absolute value, absolute value is going to be a non-negative quantity. And just in the case of examples of absolute value, you have something like the absolute value of 14 is equal to 14. Absolute value of a positive number is going to be a positive number. And likewise, the absolute value of a negative number. They have like that of negative 37. Absolute value of negative 37 is going to be 37. So you're still saying like negative 37 is 37 steps away from 0, but it'd be on the other side. And in the case of absolute value of 0, well, you're not moving away from 0, increasing or decreasing. So absolute value of 0 is 0. Now for what we have regarding absolute value equations. Okay, so just going from absolute value itself to absolute value equations. So if we have that, if k is a non-negative value, okay, so that means that k is greater than or equal to 0. That is, k could be equal to 0, or it could be a positive number, whether it's like a positive fraction, like positive 4/5, or a whole number, like positive 3, or an irrational number, like say pi. And say that if k is a non-negative value, and we have that the absolute value of x is equal to k. Say if k is a non-negative value and the absolute value of x is equal to k, then you're going to have that x, once you take x out of the absolute value bars, that's going to be equal to plus or minus k. We have that x could be k or negative k. Right. Now let's say that in the case of absolute value equations, Okay, so if we're looking at solving for x, and just kind of get squared away here. Say if we have the absolute value of x is equal to 7. Right, so we're looking at solving for x, okay, and so we're looking at determining those numbers that will have an absolute value of 7. So here k is represented by 7. 7 is not negative, okay, so there will be solutions in x. And again, those numbers will be 7 units away from 0. They're going to have 7 itself and also negative 7. So x is equal to plus or minus 7. So those would be our possible solutions in x. And if we have something like an expression, okay, say we have the absolute value of 2x minus 7 followed by the addition of 2 is equal to 19. Okay, so we have the absolute value of 2x minus 7 plus 2 is equal to 19. So you don't have yet the one-to-one lineup between the absolute value of the expression and the constant k right yet, because we had that plus 2 that's creating a bit of an obstacle. But we can just move the 2 over. And in the rewrite, so we're going to have the absolute value of 2x minus 7 is equal to 17. Okay. And we have a one-to-one correspondence between the absolute value of an expression on one side and the constant on the other. So you have x represented by 2x minus 7, k is represented by 17. And if I take out the absolute value notation, we're going to have 2 pathways for 2x minus 7. And it'll be equal to those numbers that will be 17 units away from 0 on the number line. So one is going to be positive 17 and the other negative 17. And finding out what values of x will set 2x minus 7 equal to positive and negative 7. Yeah, 2x minus 7 equal to positive or negative 17. So you have for 2x minus 7 equal to negative 17. And for 2x minus 7 equal to positive 17. So if I isolate the x term for both equations, so I can add 7 to both ends. At the lower end, okay, we have 2x equal to negative 17 plus 7, so we have a negative 10. And if I divide by 2, so we have that x is equal to negative 5. Now for 2x minus 7 equal to 17, if I add 7 to both sides, so we have 2x is equal to 24, and we have a division by 2, okay, we'll come out to x equal to 12. So x will have 2 solutions. At the lower end we have at negative 5, and the other, okay, we're going to have at positive 12. And let's say that if we have another case here, and we'll say we have that the absolute value of x plus 5 is equal to negative 16. So yeah, the absolute value of x plus 5 is equal to negative 16. Now we have one-to-one correspondence. We have the absolute value of x represented by x, and k is represented by negative 16. But again, stressing the non-negativity part. Absolute value is a non-negative quantity, and k is supposed to be a non-negative value. So just And taking what we have here, whatever we have the absolute value expression set equal to, the constant cannot be negative. So we have, in consequence, there will be no solution. Now, that's a little bit of an added case, and this is same nature in the type of problem, but just a little added dimension in terms of the problem solving treatment and how to go about isolating the absolute value expression. Say we have negative 3 times the absolute value of 2x plus 6. We have plus 6 is equal to negative 24. Okay, so this is the first case where we have explicitly a coefficient in front of the absolute value notation. And what you're going to do here is that you're going to treat the absolute value of 2x plus 6 differently from where you would have 2x plus 6 in parentheses. Okay, so you're not going to distribute so in other words, do not treat the absolute value of 2x plus 6 as you would if you had 2x plus 6 in parentheses. So in other words, we cannot take direct distribution and say we have negative 6x minus 18. So you're going to have to work around, okay, the absolute value symbols, okay, with the outside coefficients. So for what we have in this setup, okay, so just like what we did with the earlier case, I had addition of 2. Here I have the addition of 6. So I can just remove that constant by subtracting. And so we're going to have in the rewrite, okay, we will have negative 3 times the absolute value of 2x plus 6. And we'll have is equal to negative 24 minus 6. Now negative 24 and negative 6, okay, this will be at negative 30. And again, I cannot distribute negative 3 over 2x plus 6. Now you might have a solution, but it might deny you of a second solution. So in terms of what to do with the negative 3, I'm just going to divide on both sides. Alright, so with division by negative 3, okay, so left hand side, we have the absolute value of 2x plus 6. And to the right, have negative 30 over negative 3, so this will be a positive 10. Okay, so finally, it took quite a few operations to get it to the format of the absolute value of x is equal to k. Now the k value is going to be at 10, and as I remove the absolute value of bars, so we have 2x plus 6 is equal to the numbers that will have a distance of 10 units away from 0. Okay, one at 10 and the other we have at minus 10. And looking at solving for x, okay, so setting up our equations. So you have 2x plus 6 is equal to negative 10, or it could be that 2x plus 6 is equal to positive 10. And we have with the simultaneous equations. So if I isolate the x term by taking 6 away from both sides, so we have 2x is equal to, and negative 10 minus 6 is going to be negative 16. Division by 2, so this will lead to x is equal to negative 8. and taking 6 away from both sides in the second equation. So we're going to have that 2x is equal to 4, and with division by 2. So we have that x is equal to 2. And so we have for x, there will be two solutions again, one negative and the other positive, which we have with -8 and 2. All right, and let's say that for what we have in working with absolute value. And tell you what, let's see what we get. So we have solving for x. Okay, so we'll say that we have that the absolute value of x is equal to 15. And we'll say that we have the absolute value of 2x is equal to 22. And we'll say we have the absolute value of x minus 22 is equal to -10. And we'll say that we have as a fourth case, and we'll say that we have -4 times the absolute value of 3x minus 2 plus 10 is equal to -54. Okay, so for the next few moments, let's see what we get for x among these four absolute value equations. Okay, for what we have among these four problems, we're looking at seeing if we have any solutions for x, and if there are, we're to identify them. Okay, so we have at the start, okay, so we have first items, okay, we have the absolute value of x is equal to 15, okay, and so we have k represented by 15, which is a non-negative number, and so we are going to have solutions for x, and so if k is at 15, then x is equal to plus or minus k. So we have those numbers that will be 15 units away from 0. And those numbers will be positive and negative 15. Okay, for the second item, okay, so we have that the absolute value of 2x is equal to 22. Okay, so as take care of the absolute value bars. Okay, so we have going from absolute value of 2x to 2x. Again, 2x is going to be 22 units away from 0 on the number line. And values that are 22 units away from 0, we have 22 as well as -22. So looking at the values of x, that will ensure that 2 times x is going to be 22 units away from 0. And we have for the possible values, we have at the lower ends, we have 2x is equal to -22. And at the upper end, we have that 2x is equal to 22. So we're going to end up with additive inverse values. Okay, so we have x is at -11 whenever 2x is equal to -22. And for 2x equal to 22, we have that x is equal to 11. So just going back, 2 times -11 is -22. And the absolute value of -22 is 22. And again, 2 times 11 is 22. And the absolute value of 22 is 22. So we have, in this order, we have another set of additive inverse solutions with negative and positive 11. Now, for what we have in the third item, we have that the absolute value of x minus 22 is equal to minus 10. Okay, and for what we have here, okay, we have the absolute value of x represented by that of x minus 22, and k we have represented by negative 10. However, k is supposed to be a non-negative value, and since we have k on display as being at negative 10, if we had a positive 10 instead, we would have had sets of values for x in the solution. But here, because of the negative sign, we cannot have that which represents k to be negative, so we have no solution. Now, for what we have in the fourth item, okay, so we have an absolute value equation, and here we have, again, in terms of getting the absolute value of 3x minus 2 by itself, here we have a couple of obstacles to remove. One is going to be 10, which is added, and so we're going to subtract. So we have in the rewrite, so we have negative 4 times the absolute value of 3x minus 2 is equal to negative 54 minus 10, so this will be a negative 64. And again, taking care of the coefficient negative 4, which will be done not by distribution, but by division. Okay, and so with what we have here, okay, we have the reduction down to the absolute value of 3x minus 2 is equal to, and for negative 64 divided by negative 4, this will be a positive 16. Okay, so k is at 16, absolute value of x is symbolized by the absolute value of 3x minus 2, and upon dropping the absolute value bars, so we have 3x minus 2 set equal to those amounts that will have an integral distance of 16 units away from 0. And so those numbers have at positive and negative 16. So in setting 3x minus 2 to negative 16 as well as 16, and we're going to have in the setup, so adding 2 throughout on both sides of both equations. So we're going to have 3x is equal to negative 14. And also we have 3x is equal to 18. So for what we're going to have at the lower end, with division by 3, we have negative 14 thirds. And with the same follow through for what we have at the upper end, we want to have the x is equal to 6. Okay, so for the solution sets, okay, we have a negative and a positive value, respectively, with minus 14 thirds and positive 6.